Yes, for sure.
Okay.
Let me just quickly complete this topic, the potential divider, and we can discuss the questions because they are very important questions. Can you tell me the paper, paper and variant is this, or it will be easy for me to just go through that?
Uh, okay. 062541 October November 2019.
ON 219, okay, and it's
Paper
paper four
41.
four one. All
Yeah.
right, right. Okay, we'll discuss it. Okay, so these are the two components, and one is called thermistor, and the other one is called LDR. Thermistor is temperature dependent, and LDR is basically light dependent. If temperature increases, the resistance,
So what's the use
full
of both?
form, yeah, I'll tell you. Thermistor is basically used in circuits where we have to, like, for instance, a fire alarm. So when it's fire, as soon as fire is there, so temperature is going to increase. Okay,
Yes, sir.
and then what's going to happen
सर आपकी आवाज बहुत कट रही है
for all of you?
नहीं सर।
सर आपकी आवाज कट रही है बहुत
तो rejoin करो. When the temperature increases, resistance decreases. Okay, so that means more current flows and voltage decreases. This is for thermistor. Okay, so when there is a greater current, or we can say when there is a greater temperature, so resistance of thermistor decreases. Okay, when the resistance of thermistor decrease, what happens? More current flows and okay, where do we use thermistor, by the way? Just think of a circuit where there is a fire alarm connected. There is no one to switch. There is no one to switch on that fire alarm. Okay, so what's going to happen? That you have put thermistor over there. There is fire. Temperature is increased. So as soon as thermistor detects that there's more temperature, so what's going to happen? That its resistance decreases. Current starts flowing more and more. The circuits get switched on, and we can have a buzzer or alarm being rung. Okay, so this is what thermistor is doing. Okay, for LDR, LDR is light dependent resistance. Okay, these symbols are very important. LDR depends on light. So you can have two conditions, either it's dark condition or either it's bright condition. Okay, so when brightness increases, the resistance will decrease, current increase, voltage decrease. Okay, so what happens? Just imagine, like, there's something, for example, Ziad, can you tell me one use of LDR?
Light dependent resistor and light lamps on the street. Street lamps.
Street lamps, yeah. So what happens?
Uh, so in street lamps, when it's nighttime, the resistance will increasing, and that will allow the bulb to light up.
Okay, so where you have light sensors or street lights. All right. Okay, just think about a burglar alarm. Burglar alarm, like someone is stepping in with some light. There's just darkness. Okay, some intruder has just set in with some light, a torch light. Okay, as soon as the LDR is going to detect some light, So its resistance decreases, current starts flowing in, and the alarm buzzes. Got it? LDR works on bright conditions when there is brightness. Are you getting or not?
Yes, sir.
Okay. So Ziad gave us the example of street lights. So when there is light conditions, okay. So what's going to happen? Like you want to like switch on the street lights. Okay. So it's going to sense out like under the bright condition, the resistance decreases. It's going to
Sir, for
put more
LDR,
current. Mhm.
sir, for LDR, can it also, detect movement? Like when there's movement, the light will turn on, but then if there's no movement, it'll turn off.
You can say this as well.
Okay.
It can sense brightness. Okay. And
Okay.
light intensity is more, so it works on that. Okay. Now these two components will be given in a circuit. That's what we call the potential divider. Okay. That's what we call the potential divider. So a potential divider is basically this is one of the most important topics. Okay. So a potential divider is like this. Let's suppose this is a thermistor and we have put the potential divider over here. So now what does a potential divider do? Potential divider is going to take the voltage that's called the input voltage, split it up and give some of the part of that voltage to another external circuit. So like you are splitting up the voltage in two parts. Okay. The component along which you have placed the thermistor, the potential divider is going to be called R1 and the other one is going to be called R2. If you're supposed to find the value of V out, this is going to be a three marker. Okay, Umar, the question which you were stuck in is going to be solved like this. So V out is going to be R1 over R1 plus R2 multiplied by V in. Okay, so make sure that along the component, the potential divider is connected. That's going to be called R1 always. Okay, so now quickly solve this problem. The fixed resistor is 4 kilo ohms. Okay, and you've got a thermistor that is around 3 kilo ohms. If you have placed the potential divider over here, the input voltage is, let's suppose, 100 volts. Okay, you need to find the value of V out. Okay, you can cancel out the kilo because they are the same units. Just let me know what we are getting quickly. Can anyone confirm the answer, please? So you're saying that it's 3 over 7 times 100. Is this what you have done? Okay. No, I told you you should have the one along which the component is the potential divider's fix is going to be R1. This is along which the potential divider is fixed. So this should be called
Sir,
R1 and the other one is R2.
may I answer it for 42.8 RMs?
And 2SF it's 43 ohms. Okay. Have a note of this, then you're going to move on. Oh, sorry. Yes. Sorry. Good. Should be in volts. Okay, or you can write a big V. Can you move on? Okay. There are four possible cases you need to remember, okay? Two for thermistor and two for LDR. Try to think about this, please. Yeah, this is important. So basically, a thermistor is going to show less resistance, okay, less voltage under high temperature. Now the question is this. Let's call this case A. Let's call this case B. The question is under what conditions we can obtain greater value.
Sir, can you repeat again what's thermistor?
Can you repeat? क्या कह रहे हो? Thermistor basically is temperature dependent. Okay. Temperature dependent means that when the temperature increases, the resistance of thermistor decreases, and we are going to have a lower voltage, or the output voltage that is given because of thermistor that is going to be lower. Okay. Now just listen, look at what I'm telling you. This is so important. I need to get a higher value of V out. Okay. V out is basically R1 over R1 plus R2 times V in. Okay. You have got two scenarios. In the first scenario, you're getting V out from the thermistor. And in the second scenario, you're getting V out from the fixed resistor. Okay. So the value of V out is going to be greater when the numerator is bigger. Obviously, it's quite obvious that when your R1 is
Yes, sir.
greater, R1 is greater, V out is going to be greater. Okay. In this case, this is R1 and this is R2. Okay. In this case, this is going to be R1 and that is going to be R2. So now you have to tell what must be the conditions for scenario number A and what must be the condition for scenario number B for which you're going to have a maximum output voltage. Okay. For scenario number A, your potential divider is connected across resistor. That is thermistor. Okay. So thermistor will give a greater resistance when the temperature is lower. Are you getting? Because if this is big, then this is big. Are you getting or not?
Yes, sir.
Yes, sir.
Isn't it? Okay. So thermistor is going to give a higher value of R when temperature is low. Because when temperature is high, the resistance is going to decrease, more current flows, voltage drops. Okay. So for A, we are going to write under low temperature. Okay. Thermistor will have greater resistance, thus V out will be greater. Is this clear to all of you?
Yes, sir.
Yes, sir.
जी
Okay. Now let's see. Now we have placed the potential divider across the fixed resistor and make sure that the value of fixed resistor cannot change. So there must be some alteration in the thermistor. Okay, just think about that. Think about that. There are two kids, A and B. I have to divide $10 among them. If A gets 2, B gets 8. If A gets 8, B gets 2. Okay. Firstly, I was concerned with B. Okay. Now I'm concerned with A. Are you getting, like, my point is clear? I wanted to have a greater
Yes.
resistance for the thermistor. Now my potential divider is not across the thermistor. So I want the resistance of thermistor to decrease. So when the resistance of thermistor will decrease, there will be a lower voltage across it, and automatically there is going to be a higher voltage coming in to the fixed resistor. Yes. So can anyone tell under what conditions I'm going to achieve a maximum voltage? तुक्का नहीं लगाने, you have to like think and then tell. Reasonable answer. Okay, look at the formula. Look at the formula. The formula is V out equals to R1, R1 plus R2, okay, into V in. Now my R1 is fixed. I have to do something with R2. And if R2 is bigger, ultimately this is going to decrease. And if R2 is smaller, then this is going to increase because R1 has a fixed value, it cannot change. Under what conditions the thermistor is going to give a, a, a lower value of voltage?
Sir, there
Hot
is
temperature.
less what? Yes.
Hot temperature, isn't it? Okay. So under high temperature, thermistor will have higher resistance. Okay. Am I right? No, it's going to have lower resistance. Okay. So potential difference across thermistor will be lesser, and potential difference across fixed resistor will be greater. Therefore, V out will be greater. I can see that my screen is not sharing. Just wait for a second. Inshallah, it's going to come back. Okay. Who is clear with this and who is not clear with this? Just frankly speak out. I'll explain again.
Sir, I understood.
What were you saying? You don't understand? Ji, yes, Umar. Mm-hmm. अच्छा, सिंपल वर्ड्स में एक्सप्लेन करने, दूसरा वाला पॉइंट समझ में आ गया, फर्स्ट वाला नहीं आया। फर्स्ट वाले में देखें आप कि आप फर्स्ट वाले में you're having the potential divider connected across the thermistor. Okay, so so I need a greater value of R1 because R1 is the resistance. Okay, so I need a greater value of R1. Exactly, exactly. हाँ, तो वोल्टेज रेजिस्टेंस के डायरेक्टली प्रोपोर्शनल होता है। नहीं नहीं, डायरेक्टली प्रोपोर्शनल होता है वोल्टेज रेजिस्टेंस की थर्मिस्टर में। ओके, अब I'm exactly, I'm explaining it once again, the whole thing. Just look here. Your potential divider can be connected in two ways. Number one, it's either connected to the thermistor, which is case A, and it can either be connected not to the thermistor but to the fixed resistor, that's case B. In both the scenarios, we can be asked, like it's a 3-mark question, okay? You can be asked to know under what conditions you're going to have a maximum output voltage. The formula for output voltage is going to be R1 over R1 plus R2 times Vin. R1 is whatever component you are having, the one across which you have connected the potential divider, that's going to be R1. In scenario A, R1 is the thermistor. In scenario B, R1 is going to be the fixed resistor. I want to have a greater value of V out. If you look at the formula, I need to have the numerator bigger in both the context. Okay. In the first one, because the thermistor is connected to the fixed thermistor is R1. So how can I get the value of R1 bigger? Only then I'm going, just look here. If this is bigger, ultimately that's bigger. Okay. So how can I make R1 bigger? So if we just go back and like recall, so we just stated that resistance of the thermistor increases when the temperature is lower. So if we drop the temperature, we are going to have a greater resistance of thermistor and a greater potential difference. Okay. So I hope this makes sense now. All right. For the second one, the thermistor is connected, the potential divider is connected to the fixed resistor. I cannot do anything to the value of fixed resistor. I have to make changes in thermistor. So if the output voltage is to be found higher across the fixed resistor, so I have to drop the potential difference across the thermistor. Okay, because the potential difference is going to get divided amongst those two. If one gets less, the other one ultimately is going to get higher one. How can I do this? So under what condition the thermistor is going to have a lower potential difference? Only when it's going to have a lesser resistance, and it's going to have a less resistance at high temperature. So if you increase the temperature, the resistance of potential divider, the resistance of the thermistor is going to decrease. Okay, and ultimately it's going to produce a lesser voltage over here, and you're going to have a greater voltage supplied to the fixed resistor. So the fixed resistor is going to provide the output voltage, so it's going to be bigger. Clear?
Yes, sir.
All right, done. Okay, let's move on to LDR. So LDRs are basically the light dependent one, and they work under bright conditions. Okay. So the second one is going to be LDR. Now you have to talk about dark and bright. Okay. Something quite similar to what you studied. So we have got an LDR. I place the potential divider over here. That's V out, and that's V in. Okay. This is scenario A, and that's going to be scenario B, where you have connected the. Okay, ji. So under what conditions okay, for LDR, if we have more light, that means brightness, then the resistance of LDR is going to decrease and we will have a low voltage. Okay. And when we decrease the brightness, or we can say the darkness, and under dark conditions, okay. So under dark conditions, you'll have more resistance and more voltage. Okay. I need to have a greater V out. Just think about it and tell me. Like 1 minute. Be quick. For the first one. Okay. So for the first one, I need to have a greater value of R1. And R1 is going to be LDR in this case. Okay. So when is going to be R1 greater? Under dark conditions. Okay. So I can write under dark conditions. Exactly. Under dark conditions, LDR has greater resistance. So PD is potential difference of voltage, okay, increases, and hence greater output voltage. Okay. Scenario B, we want lower resistance from LDR, okay, because your fixed resistor will have a greater voltage. Only when LDR will have a lesser voltage. Okay. So under bright conditions, LDR has lower resistance. Okay. So less PD across LDR, greater PD across fixed resistor. Hence greater V out. Haji, is it clear to all of you? आ जाएगी आ जाएगी आ जाएगी आ गई कहीं नहीं जाती okay ji this was one of the complex topics and Alhamdulillah I have just made it clear. Now you guys can just copy down and let me know if you have any confusions. All of you can ask freely any questions you have. Explanation, yeah, explanation. A 3 mark question where you have to write down. You can have a potential divider like numerical problem as well, and you can have explanation questions as well. So solve the past papers, okay? जाएं और आप do solve the past papers. Okay. Now I want to discuss one of the paper. Yeah, my dear bachas, just I have seen these papers 2017 and 2018 papers. They are very challenging to be honest. Okay. I have assigned you अपनी responsibility समझ के you guys are going to solve these papers all three variants, okay? 4-1, 4-2, 4-3, summer 17, okay, and winter 17. Same goes for winter 18 and summer 18. Believe me, this is going to give you very good marks if you practice them. Challenging papers. ठीक है भाई? सर वाला मशवरा है और भाइयों वाला मशवरा भी है that you are going to just okay भाइयों वाला मशवरा भी है ठीक है भाई गलत मशवरे नहीं देते okay. All right. Now Ziad has done a paper and let's solve it. 4-1 October, November 2019. Okay, just let me quickly go through it. So we're just going to discuss the problematic parts over here quickly, okay? I want you guys to open this paper as well. October, November 2019. That's a very challenging paper. Like the COVID time was going on. October, November 2019. Paper 4-1. It's not there. I have to download this paper. Okay, inshallah, tomorrow's class we are going to talk about some what's left in electricity. We have done the graphs. We have done like okay, we do the past papers tomorrow, inshallah, for electricity. The filament lamp graph. Do you remember? Ah, yeah, clearly, na? Okay, ji. So this is a paper discussion. I want all of you to be with me and just let me know if you have any troubles. Okay, Ziad, I want your attendance over here. So first of all, we want to find the acceleration of the car. Acceleration of the car is between 0 and 5. So it's a straight line, okay? Yes, yeah.
Okay, wait, let me just pull up my papers.
Yes, sure.
Yeah. Acceleration should be 3 meters per second square.
Yeah, so it's a straight line. Just use the gradient formula. Okay, there's a certain force acting on the car, so they have given you the mass time, acceleration. Okay, that's it. Motion of the car between 10 and 15. How the graph shows this? You have to talk about the motion of the car. So this is speed time graph. We can discuss this in terms of acceleration, or we can discuss this in terms of speed. Can anyone voluntarily try to explain this graph? I want Shazin to answer, and Zainab, you just think about it, and then it's your turn.
Sir,
Think.
between 10 to 15 seconds, the car is experiencing decreasing acceleration.
Okay, and why? Describe the motion of the car. Explain how the figure shows this. Okay, so you can see here that the graph is getting less steeper. Very good, Shazin. Okay, so the graph is getting less steeper. Okay,
Yes,
the
there
graph.
was a straight line between it, but now it is curving.
Okay, yeah. So we can see non-uniform decreasing acceleration. Okay, how we are, the car is having non-uniform decreasing acceleration because the gradient of the car is getting gradient of the speed is getting less steeper. What might be the reasons for
Yes.
this? They can ask you like, why is this happening? So you can say that because resistive forces are acting on it. Okay, friction, air resistance, these are the forces that Ziad, is that clear?
Yeah.
Okay, the force exerted due to engine remains constant. Explain why the car moves in the way shown. Yeah, exactly. That's the question. Okay, I just think of the question and that it comes. Believe me, I haven't seen this question. Okay, state two properties of an object that may be changed by the action of force. Yes,
Its shape,
shape, shape, speed. Yeah, yeah. Shape can change, speed can change, direction can change. Okay. Next part, they're saying state what is meant by the statement. It obeys Hooke's law. Stress the load is directly proportional to extension and within the limit of proportionality. They want you to find the okay. So state the tension in each spring. Each athlete pulls the handle towards himself with a force of 1300 Newton. State the tension in each spring. Yes. Ziad, what was your answer for this?
Hold on. Let me get that paper.
Exactly. Exactly. They haven't asked you to calculate. They're just saying state the tension. 1300. That's it. Hmm. Exactly. Okay. For the spring that is on the hand of the person on the left side, the tension is acting towards right. Okay, they're exerting the same amount of tension, so that's going to be 1300. Okay. Now they have given you the extension. They have given the extension. You have the force. Okay. But this is not the extension. This is the new length. Can anyone tell me how can we find the
Sir,
extension?
New
sir,
length
by
means
calculating the
old length.
difference between the extended length and original.
Exactly. But you have been minus original length. Unstretched length is there. Okay. So new length is 0.94. You subtract it from the unstretched length, you'll get the extension. And we know that the Hooke's law is F equals to Kx. Okay. So yeah, so we are just supposed to find K. Okay. F equals to Kx. So we are supposed to find K equals to F over X. That's it. All right. Is that clear? State the energy changes at the athlete uses muscles to stretch the chest expander. Chemical energy, okay, into elastic potential energy. That's it. Impulse is a chemical energy, like your muscles. Whenever there's a human activity, it's chemical energy. Okay. Hanji. Next one. Ziad, impulse.
Impulse when an external resultant force acts on an object for a short amount of time.
Yes, the product of the
sir.
hmm?
Sir, impulse, defining basically impulse is change in momentum.
Hmm. No, 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 no. Yeah, yeah, yeah. Rate of change of momentum नहीं होगा. Yeah, तो simply you can write change in momentum. But a better definition was Ziad has told us. It is the product of force for a short interval of time. Delta P equals to F multiplied by T. That's the better answer. Okay. So you have been given the value of mass. You have to find the speed. So you have the impulse. Okay. You have the impulse, you have the mass. So impulse is simply the change in momentum. Okay. And change in momentum is mass times change in speed. Okay. Are you getting? So you're supposed to find this. You just divide the change in momentum by the mass, you're going to have the change in speed. Okay. Got it. And now you have to find kinetic energy, so you're going to use 1 upon 2 mv squared. Okay, so that will give you 3 marks. Easy peasy. अगर impulse का topic किसी के लिए मुश्किल है, नहीं समझ आ रहा, just let me know. I'll explain again, inshallah. The parrot melts when it strikes the target. Describe how the molecular structure of the liquid metal differs from that of the solid metal. This is something related to chemistry, okay? Something related to that. You just have to define the structure. Okay? A random arrangement, slides. Exactly. You just have to talk about that. Yeah, this one. Yes. How the cone of the loudspeaker produces the sound. So you guys must remember that sound is only produced because of vibration. So there must be some vibration in this, okay?
So there is
So I've
an electric current passes through like a motor or a source of sound. The source of sound produces vibrations, and then the hollow paper cone amplifies the vibrations.
good. In the next part, you're being asked to find the wavelength. So if you know the formula, V equals to F lambda, you're supposed to find lambda. Your lambda equals to V over F, okay? Then these are the wavefronts. These are diffraction quotients, okay? Diffraction. So you can just see the gap is so big, okay? So you're going to draw the wavelengths, the wavefronts, okay? And the wavefronts are going to be double the wavelength, okay? So they have told us that this is double the wavelength. So you can just draw something like this. Okay, these are the wavefronts. And we know that when this gap is so big, so the wavefronts, instead of being curved, they're going to be straight.
Sir, there will be less curvature.
Exactly, but okay. And if you want to be more specific, you can just measure this. Okay, whatever this length is, let's suppose this is 10. So this distance should be 5 between all of them. Okay, for instance, to be more specific. But I don't think so you are required this one. Okay, you just give. Exactly. Yeah. In the gap, you're just going to have something like this. So when it's going to go, and then it's going to spread out. Okay, something related to electrostatic. Arrows to show the pattern and direction of the electric field. So we have negative charge. Field lines are going to come inside the charge, okay? By drawing on figure, indicate the distributed charge on S. So all the positive charges are going to be attracted towards the negative source, and the negative charges are going to be repelled, okay? So plus 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 over here and negative negative over here, okay? An earth wire is touched against S. Describe what happens in the wire state, how this affects the charge on S. So what is the earth wire going to do? Negative charges, okay? So this can be exactly. The plastic thread electric insulator, explain the difference structures of the two materials, free electrons, no free electrons, okay? Okay, we haven't studied this till now, but we have studied this specific capacity thing. So my dear students, I have told you about this power thing. So electrical current, okay? Exactly, so current is going to be P over V. You'll get the current, okay? Whatever the current we are getting, fuse rating, inshallah, we'll discuss later on. Now you're supposed to find the maximum mass of water. Okay, and there you have given the time. So E equals to mc delta T. Okay, you have to find the mass of water. Okay, in 1 second. So that is basically the mass flow rate. We don't have E. We don't have E. So let us divide both sides by time. So this is going to be power. We do have the value of power. Okay. And for instance, sometimes they give like the heater is 60% efficient. So I'm just going to write 0.6 times of P, not the whole thing. Okay. So we have to find this mass flow rate. C is the specific heat capacity. Change in temperature is 35. Okay. And this time is just 1 second. So no need to bother about this. So you have to find this. So M over T is going to be P times P divided by C delta T. Okay. So you get that. So it's 4 marks. Easy peasy. Okay. Thermocouple is no more in the syllabus. Just leave it. No thermometers. Nothing. Okay. All right. Something related to this. Inshallah, we'll study this then later on about the resistance wire. And this is when the figure sketch a graph to show.
Wait,
So
sir.
this is
So is thermocouple just not part of our syllabus, or
exactly no. It's no more a part of syllabus. Else I would have taught you that. You must have been bothering about what to do with thermocouple. For this question, just wait till tomorrow. Okay. I'll solve you this for tomorrow. Like
Okay, fine.
you have been given the refractive index. Okay, you have to find the value of you have been given the incidence and refraction. You have to find the value of refractive index. Okay, just apply the formula. Get the answer. Okay, so we have covered this thing. Ex- it can be. Some they do shuffle. Okay,
So that's it.
and that's it.
Okay.
Okay. Nuclear physics we are going to study inshallah once we are done with electricity and magnetism. Okay, so we are just quickly coming up to the thing. Okay, so suggestions for you guys is to solve papers from 2018, please. Okay, yeah, 17, 18, please do them. Okay, Siad, I do know WhatsApp calls do not work in Dubai, but at least you'll get a missed call. Okay, to get you give alert that the class has started. All right, my dear students. Wait, Aban hai हमारे पास. Aban, how was the class? Feedback. If you can speak up.
It was nice, sir.
Alhamdulillah, that's great. Okay, join us. Okay, then I'll be waiting. Okay, ji. So see you guys tomorrow, inshallah. Okay, do the work and Abdurrahim send me the test. See you guys then. Zainab and Ali, I'll send you the time for the class. Okay, I think inshallah within an hour we'll start. Okay, be
Okay.
ready. Allah Hafiz. Time for namaz.
Allah
Allah
Hafiz.
Hafiz.
Allah Hafiz, sir.
Yes.